Thank you for joining us for today's webinar, Navigating Custom Load Cells, a guide for what you need to know. My name is Nikki Chris. I'm the marketing manager here at Interface, and I'll be your hostess for today's webinar. Our presenters today are Interface Applications Engineer Ken B., Senior Project Engineer Brian S., and Design Engineer J.B. Ken has 18 years of experience in load cells and holds an MBA from the University of Redlands. Him and his wife just bought a new house. Brian has been with Interface for 22 years. He attended Weber State University in Ogden, Utah, where he earned a degree in automotive and mechanical engineering technology. In his free time, he flies helicopters. Jay has been designing instrumentation and custom electronic load cell components at Interface for 10 years. He has over 20 years experience in sensor electronics design and has been in the field for over 30 years. Jay plays guitar and has even built one from scratch. Our agenda for today's webinar is as follows. First, we will cover the determining factors for load cell customization and some of Interface's capabilities. Then, we will go over some brief definitions, followed by the features of a standard load cell. After that, we will discuss special adaptation versus pure custom and give some examples. We will tell you why people choose Interface for their custom load cell needs. Finally, we will open it up for some Q&A. Now, without further ado, I'd like to pass the mic over to Ken B. to talk about the determining factors.
What determines whether or not you will need a standard product or a custom product? Your application, the environment your application is operating in, the size of the load cell versus the capacity you need, the performance specifications, connectors and cable lengths, your mounting needs, your output needs, and whether you've got an OEM application. Brian will explain more about the environment.
The environment is how hot or cold it needs to be. Our standard low profile has an operating range of -65 to 200 degrees Fahrenheit. You also need to think about if it's going to be a dry environment or if it's going to have high humidity in the area or if it's going to be in a wet environment, which may also be submerged. You're going to be using it indoors or outside. If it's outside, we're going to ask about if there's any shielding or environmental protections around the load cells. You may also consider if it's going to be in a laboratory or an industrial environment. So if it's in a laboratory, it would be in a controlled atmosphere used for calibration or maybe a reference load cell. Industrial applications could be an assembly line, process control, or if you're an OEM type user, you may install it and sell it to your customer. Several applications in the oil and gas industry have very specific requirements for their environment. And we make our load cells out of several different materials, whether they be alloy steel, aluminum, or stainless steel. And these are based on the capacity of the load cell and the environment that it's going to be operating in. Sealing of the load cell can be achieved through either bonding or welding of diaphragms to cover the gauge area so that that doesn't get damaged and protect it from whatever environment there is. We also have questions about vacuum applications, and these have additional considerations depending on how high or how strong the vacuum is and whether outgassing of materials needs to be minimized. Last on the environment is electrical noise that may be coming from electric motors, arc welders, maybe linear actuators that are in the area. And these need to be considered as well to avoid degrading in the load cell signal. Now we're going to talk about size versus capacity. The physical size of the load cell is somewhat driven by the capacity and the available space that you have. We do many custom size flexures, bases, and adapter assemblies to fit specific applications. A custom capacity may be a new flexure, or it could be a standard flexure calibrated at a different value. Example would be taking a 12, 20, 25K flexure and having it calibrated to 15K, which would give you an output of 2.4 millivolts per volt. With that, you also get a higher safe overload rating because it's still a 25K flexure that you're using. And you could also have the flexure calibrated at 25K or another capacity to use in a different application later on. As you get close to the limits of size and capacity, whether you have a small part with a high load or a large part with a small load, the performance generally starts to suffer. Strain gauges work best when the stress flow is parallel to the grid lines. So if the flexure doesn't have proper design considerations, then that may not happen and it induces more errors into your part. An example may be a 1210 10K flexure. Works great in the 10K and 50 kilonewton capacity. As you start to push beyond those limits up into maybe 11.5, 12K, then the performance begins to suffer because components of it begin to bend instead of working shear. So large load cells for low capacities generally won't have very much output, or they become very fragile if you have large masses in a very small gauge area in order to get the output that you need. And next we're going to talk about some performance specifications. So as the end user, you need to determine what performance limits you need based on your particular application. Some people may focus only on the nonlinearity and hysteresis or our SEB specs, and you also may need to think about how the flexure is mounted, which I will discuss further in a moment. Maybe for your application, you need more data points, either ascending or descending, to better characterize the performance of the load cell. You may have an application where the operating temperature is outside the advertised compensation range. And in some cases, we'll perform additional testing if you require it. Now we're going to talk about some mounting needs or considerations. We have several options as far as mounting that we've assisted customers with in the past. So on either end, you may have male or female threads, thread adapters similar to what we use in the 1600 load cells, integral studs, which is similar to what we have in the 1800 series load cells. We have a flange mount series, which are typically used on cylinder applications, and you can also use clevises or rod end bearings in tension applications. The flange mount has the advantage of being able to be mounted using several bolts on the hub rather than a single female thread in the center. We like to have those center female threads torqued so that there's no movement or play in that thread, and that can be difficult in some applications to get that thread tight enough. As far as mounting the load cell to a fixture, we recommend that fixture be 2/10,000ths of an inch flat, and in applications where we're using steel load cells, we want the hardness of that plate to be in a Rockwell C scale of around 30 to 32. It needs to be fully supported, and we need to use good mounting bolts in grade 8 or better and have those torqued properly. If you purchase the flexure with a base, then you'll be a lot closer to the cal sheet data at your installation than if you purchased without the base, because it was calibrated as an assembly. And as long as the hardware that you're mounting the load cell to, if you purchase one without a base, meets our criteria, then you should be very close to the calibration data that we supply for you. We can also install adapters to make your standard flexure fit a custom application. You may have a requirement where you need a 1¼ 12 female thread, but you want to buy a 4 1/8 inch 10K flexure, which comes with a 5/8 18 thread. So then we could make an adapter to go between, to get to the 1¼ 12 female and install it and calibrate it when we do our calibration on your load cell. So I'm going to pass it out to Jay to discuss some connectors and cables.
Yeah, Ron. Cables and connectors. All of our standard load cells come with either usually a circular Amphenol type connector or an integral cable. Our circular connectors come in both screw type or bayonet, 6, 8, or 10 pins, depending on the model. Some of our stainless steel load cells, the 2400 series, for example, have a hermetically sealed bayonet connector as a standard feature. Integral cable load cells generally come with for a larger load cell, usually is a 10-foot cable, and there's usually a 5-foot cable on our small models, our minis. The type of cable depends really on the application of the load cell and the size of the load cell. As far as custom connectors, we've supplied Limo, Binder, Molex, and many other types. We have actual physical types, M12 metric connectors, which mate with a lot of popular industrial cables, such as Turk. RJ45 Ethernet type connectors, which allow the use of Ethernet cabling, which is low cost and actually fairly decent as far as performance. We really have all shapes and sizes of connectors. We stock literally hundreds of different types of connectors and have sources for many more. Our standard cable that we ship with most of our load cells is non-twisted pair shielded cable. There again, the size and jacketing type depends on the load cell. We also have twisted pair cables available. We have high flex, submersible, and chemical resistant Teflon wrapped cables as well. The lengths of the cables can go anywhere from 1 foot to 500 feet. So we really have a lot of flexibility in that. We design and manufacture all our cables in-house so we can adapt fairly quickly to whatever the customer's needs are. Now I'm going to talk about outputs a little bit. Our standard millivolt-per-volt output is largely determined by the load cell design and size, material of the load cell, and a few other things. It's normally fairly consistent. Our manufacturing practices are fairly tight, so we can guarantee that. Normally, all we do for compensation is for zero and offset temperature sensitivity. And for our metrology uses, this is really good practice because you don't really want to tamper with a good output. You will only make it worse. Although in some cases, a customer is going to want the output trimmed to some specific value and maybe within a tolerance, say 2 millivolts per volt plus or minus 1%, so that the calibration is always close from sensor to sensor, and there's a certain amount of interchangeability. Another case would be where the measuring equipment that the customer is using is not able to handle, say, a 4 millivolt per volt output, so we'll trim it down to 3 millivolts, or so that he doesn't exceed whatever his input needs are. We also have amplified outputs. A lot of industrial applications need a high-level voltage output or current output to interface with whatever the industrial equipment they're using. So, for example, a PLC with 10 volt inputs. We offer amplified outputs in plus or minus 5 volts, plus or minus 10 volts, 0 to 10, 5 volts plus or minus 5 volts, 4 to 20 milliamps, 12 milliamps plus or minus 8 milliamps. We've offered digital outputs, USB, RS-45, CAN bus, and Ethernet, even on some very custom units. For larger load cells, we have internal amplifiers built right into the load cell. And for smaller load cells, our minis, usually use an inline amplifier housing in the cable. Some things to remember with amplification is the basic goal of amplification is to interface the native load cell output to the end user's equipment inputs. You can't really amplify a small signal too large or you start losing your quality of your output. So you can't take a load cell and use 10% of its range and amplify it to a higher level and still expect to have a superior performing load cell with a 100 times overload. An example would be if you try to amplify a 0.5 millivolt signal to a 10 volt output, you're going to get a gain of around 2,000. And with that, you're going to amplify all the load cell errors and any interference noise that's coming into that. Now I'm going to turn it over to Ken.
I want to speak to you about OEM applications. Get an example. We had a customer come to us with a lumbar table, and they had already designed the table and had instrumentation. They wanted to get a solution that would basically plug into their system, give them the force readings, and basically plug and play. So what we did is we spoke with them about which type of load cell they needed, the size, capacity, and then we asked them what type of cable lengths that they needed. So we're going to mechanically mount this into their system. Now, how far is the cable going to have to travel? What kind of connector do they want? And what kind of, in this case, they wanted an amplified signal because that was the best way to communicate with their controls. And we put it all together under one part number, and we're able to ship this product to them, and we still ship it to them consistently. And they basically just receive it, install it into their system, and ship product. Some of the benefits of it, obviously, is you can tailor to the needs of your customer or yourself. As we go in higher volumes, we're able to reduce costs and be more effective. For instance, a load cell may be used in tension and compression, but your application may only need tension. So we would only have to calibrate this load cell in one direction. We would be very consistent, and it is our expertise to match these devices together, so it's going to be much better and, more, of course, more efficient for you, because when you receive this product, you're basically installing it and moving on to your next process. Next, I'd like to speak to you about the definitions. These definitions are what we're using in the presentation so that you'll know whether it's a standard product, an adaptation, or custom. So standard product is anything that's in our catalog or is on the website. There's many different size, shapes of load cells available, and in a lot of the cases, you're going to be able to just pick one from there and use it in your application successfully. A special adaptation is a part where you look in the catalog and you say, hey, I've got something very close, but I wish I had a different thread size, or I wish I had that part with a certain connector on it. Those minor alterations to the part won't cause a redesign of the flexure itself, and so it will be, let's say, more readily available for you, and then we categorize it as a special adaptation. A pure custom would be, let's say you want a thread size that's not available and does cause an alteration of the flexure. Now it's going to have to go through engineering for a full review of the design and go through all those steps. One other explanation we want to give you is NRE, which is a non-recurring engineering charge. And basically, if work is done to alter a standard product or create a pure custom, there'll be this type of charge associated with it. I'd like to describe to you now the standard load cell features. What we have pictured is our model 1200 series, and the upper portion that's attached to the thread on the top, we call that a flexure. And the flexure is made from different material types, such as stainless steel, alloy steel, or aluminum, and it has a strain gauge attached to it. And then underneath it, we have what's called the base. So the base is the part that Brian explained earlier, where when you attach it to the flexure, it gives you results that are very close to the ones that we get here in the factory. Integral thread would go in the place of the threaded hole in the top and basically give you a male thread to mount to. Of course, connectors on the side there we've got pictured a screw type connector, but we also offer bayonet types and others, as Jay has explained. And then outputs, as Jay explained as well. We can have our standard millivolt per volt outputs, voltage, milliamp, and other. Now I'd like to turn it over to Brian to speak to you more about special adaptations.
Special adaptations of a load cell are defined based on an option code, and that's our 3-character alpha series that's in the model number. We currently have 87 different feature categories that we use to create these option codes. These feature categories define what the connector is, special wiring, special cables, whether it has special output requirements, special threads, even down to the paint or labeling is defined in those feature codes. Sometimes when we're doing special adaptations, we end up charging have some NRE charges that we have to pass along, and those are there to cover special drawings that we have to do. If we have to purchase thread gauges, if you specify a thread that we haven't done yet, any calibration fixtures, assembly fixtures. Sometimes for the high capacity products, we may have some special handling considerations that we need to make fixturing for, or to be able to move around our production area. These kind of things generally add some lead time to the part, but it just depends on the complexity of the configuration that we're trying to make. These special adaptations can be very advantageous to OEMs, as Ken mentioned earlier, because once we finish the part and calibrate it and we ship it to you, it's ready to go into your machine or what you're using it for. And then we could also possibly set up some sort of a stocking program so that we could ship parts to you quickly. NASA is one of our bigger customers that we do some special adaptations for. And these are some integral stud load cells that we made for them recently. They're a 1200 series load cell. They were triple bridge with integral studs, and they had female threads in the base. They ranged in capacity from 10K up to 200K, which is there on the right. The integral studs were chosen to give them the best performance, as well as to satisfy the requirement for a male thread on the live end of the load cells. And now I'm going to pass it off to Jay to discuss another special application.
Yeah, this is this special application is a load button that was modified for a major medical manufacturer. One of the first things they wanted was an increased performance out of the load button. Our standard load buttons are used in normal industrial markets where there's maybe a bottle capping a line or something like that. This is a special adaptation of a load button we did for a major medical manufacturer. We had to first they wanted increased performance. Standard load buttons are used in industrial lines, for example, bottle capping or something like that. And this manufacturer wanted a much better performing load cell. So we increased the performance up to where it is really quite a good performing load cell. We had to change the size of the load button slightly and add some mounting features so that it would fit into their equipment better. We added a connector that was an ultra miniature connector to interface with our equipment. And we also added a TEDS chip. TEDS is Transducer Electronic Data Sheet, which is a memory chip that is put into the unit, and it records all the calibration data and when it was calibrated and things like that. That is kind of similar to the OEM applications where you want a standard output. Well, in this case, you don't need a standard output because the calibrations table is built into each load cell, and the manufacturer can then, or the user can then just plug this load cell into their equipment and automatically calibrate it. If the load cell needs to be replaced, you just replace it with a new load cell and it automatically calibrates. I'm going to move on to another special adaptation. This was a adaptation for an agricultural equipment manufacturer, and in this case they wanted an LP type 1200 load cell with dual bridges and dual amplifiers and also special connectors as well for that type. What's interesting about this is, although in this particular case both amplifiers had the same output, we could have just as easily had different outputs. We could have had a voltage output on one and a milliamp output on the other, or even an amplified output on one side and a millivolt output on the other side. We really can say adapt to a lot of needs. We've as well as things like amplifiers or different amplifiers, we've included other sensor functions like temperature sensors and accelerometers in load cells as well. Okay, I'm going to turn it back over to Ken now.
Now we're going to move into a pure custom part. We have two main ways we can provide a custom solution for you. One is we have some customers that come to us and say, we'd like to take a number of different load cells and have you put together a system for us. And so we've put together special boxes that bring in the inputs from those particular load cells, connect them into a box, and then they go into DMA signal conditioners or other signal conditioners that we have, and then we can create it so that it'll interface with their system as well. So that's one type. And the other types that we do are load cell or torque transducer modifications as well. So those are the ones that, let's say the thread size is larger than the standard flexure can take, so it has to go fully through the engineering process, and or if it's a custom load cell that's never been built before, that'll go fully through the engineering process. So of course on the special adaptations, you had NREs that were hundreds to thousands. On pure custom, the NREs go from thousands to tens of thousands. It requires even longer lead times to develop this type of a product. Oil and gas and medical are our biggest customers for this because their applications sometimes have more restrictions on where they're actually going to be used. And then, of course, we've already explained why it becomes a pure custom, and that's because it has to go through that full. This is a product that we tailored, the one on the right. We tailored from our model SML, which is on the left side. As you can see, a standard SML comes with a female thread. And in this case, on the right, the customer wanted to have custom mounting. On the top, they wanted to be able to insert a rod and connect through a specific thread size on the top. On the bottom, they had us put together a place so they could insert bearings. and give a rod-end effect so that the load would, even if it was, let's say, off axis, could be directed through the axis of the load cell. Besides, of course, the redesign of the Fixture, the testing fixtures in-house also had to be modified, so that's what contributes to the increased NRE charges. I'd like to talk to you about why you should choose Interface. Of course, we have the best engineering team in the industry. Many have been designing load cells for years and years, and not only at Interface, but at other load cell companies. We have FEA analysis here, and basically that means we're able to model your custom load cell and make sure that it can endure the demands or meet the demands of your application. We have a state-of-the-art CAD/CAM system so that we can create the flexures and then transfer that directly to our machine shop. We have expedited prototyping, and that's because we're fully integrated here at the factory. We are able to design our own load cells right here. We can machine them here in our in-house machine shop and do all the assembly. We create our own strain gauges, so we control all the processes, including all the test and final testing, and can ship them directly to you. We continue to expand our capabilities on our standard product lines, and also we've expanded our in-house capabilities for OEM indicator design. So that means if you have instrumentation that you'd like to have created for your specific application, we can do it right here with our team.
Okay, at this time we'd like to open it up for some Q&A. For recording purposes, we're going to cut this part out and we will show all of the questions and answers in a document below that you'll be able to download. So we'd like to thank you for joining us at today's webinar, and we hope to see you again. Have a great day.